The moon is not silent. It only appears that way from a distance. For more than half a century, we believed we had already seen everything it had to offer. 12 astronauts walked its surface between 1969 and 1972. They brought back rocks, measurements, photographs. They left behind footprints that have not moved an inch since. And then, without warning, we stopped going. The official reasons were practical. Budgets shrank, priorities shifted, the space race ended. But beneath those explanations sits an uncomfortable question that has never fully gone away. Why did humanity abandon the most ambitious frontier it had ever reached?
Hippity hoppity, hippity hoppity, hippity hopping over hill and dale.
For 53 years, the moon remained untouched by human presence. Robotic probes continued to orbit and scan, mapping every crater and ridge in extraordinary detail. By the early 2000s, scientists could claim with confidence that the lunar surface was one of the most well-understood landscapes in the solar system. A dead world, predictable, empty. Then came April 2026. 4 astronauts, Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, launched aboard the Orion spacecraft as part of Artemis 2, the first crewed mission to venture beyond low Earth orbit since Apollo 17. Their trajectory would take them farther from Earth than any human had traveled in generations, around the moon, not landing, just passing behind it. It was supposed to be routine, a systems test, a symbolic return, until they crossed into the far side. The far side of the moon is not what most people think it is. It's often called the dark side, but that's a misconception. It receives just as much sunlight as the near side. What makes it different is something far more profound. It is permanently shielded from Earth. No direct radio communication, no visual contact. A complete isolation zone. For decades, that isolation has been treated as a technical inconvenience. Signals drop for about 45 minutes during orbit. That's expected, planned for, simulated countless times. But Artemis II wasn't just another simulation. At precisely 73 hours into the mission, Orion slipped behind the lunar horizon. As predicted, communication with mission control in Houston went silent. Telemetry paused. Heart rates, oxygen levels, navigation data, all temporarily lost. On Earth, it was business as usual. Engineers monitored preloaded trajectories. Systems ticked forward exactly as planned. But when communication resumed, something was wrong. It didn't start with a distress call. There was no panic, no alarm. Just a delay, 7 seconds longer than expected, then 12, then 23. By the time the signal fully stabilized, nearly 2 minutes had passed beyond the predicted blackout window. Not catastrophic, but not explainable either. Inside mission control, that kind of discrepancy doesn't go unnoticed. At first, it was attributed to minor signal interference, solar radiation, instrument lag. Nothing unusual, but the data coming through told a more complicated story. Orion's onboard clocks were out of sync. Not by seconds, but by milliseconds. Tiny discrepancies that shouldn't exist in a tightly controlled system, calibrated against atomic standards. And yet, every system showed the same drift. More unsettling was the crew's report. When communication returned, Commander Reed Wiseman's voice was calm, measured, but his first sentence didn't match the expected protocol. Houston, we had a visual anomaly. The phrase itself was vague, almost cautious. NASA transcripts later classified it under non-critical observational irregularities. But internally, it triggered immediate review. Because there was nothing in that region of space that should produce a visual anomaly. No satellites, no debris fields, no known reflective bodies. Nothing. At least, nothing that had ever been reported. As the crew continued, the description became more specific, but not more reassuring. They had observed a faint structure on the lunar surface, visible only at a certain angle, illuminated briefly as Orion adjusted its orientation. It wasn't a crater. It wasn't geological. It was linear, perfectly linear. On the Moon, natural formations are chaotic. Impact craters, jagged ridges, random fractures. Straight lines do exist, but they are rare and typically explainable through tectonic stress patterns. What the crew described didn't match any of those known formations. Even more unusual was how briefly it appeared. Less than 3 seconds. Long enough to notice, not long enough to fully understand. Mission Control requested confirmation. The crew attempted to reacquire the visual. They couldn't. The angle was gone. The lighting had shifted, and whatever they had seen had disappeared back into the vast grey uniformity of the lunar far side. At that moment, it could have ended there. A misinterpretation, a trick of light, human perception under stress. Space has a way of distorting scale and distance, turning ordinary features into something unfamiliar. But the anomaly didn't stay isolated. As the data logs were reviewed in real time, another inconsistency surfaced. Orion's trajectory had deviated, not significantly, just enough to matter. A fraction of a degree off course during the blackout period. Within safety margins, but outside the expected tolerance for a fully automated guidance system. That kind of deviation requires an explanation. Thruster activity, gravitational interference, manual override. None of those appeared in the system logs. It was as if the spacecraft had adjusted itself, without any recorded command. Back on Earth, analysts began reconstructing the timeline. Every second of the blackout window was dissected, every sensor reading examined. But the deeper they looked, the more the data resisted a clean explanation. There was a gap, not in communication, that was expected, but in recorded internal activity. A span of approximately 11 seconds where the data stream simply didn't exist. No telemetry, no system logs, no crew input. For a spacecraft designed with redundancy layered upon redundancy, that kind of absence is almost impossible. Almost. When questioned, the crew's recollection of those 11 seconds was unclear, not missing, not erased, just fragmented. They described a moment of disorientation, a subtle shift like losing balance for a fraction of a second. Nothing dramatic, no alarms, no visible malfunction, just a shared sensation that something had changed. And then it was over. On Earth, engineers continued to run simulations, feeding every known variable into their models. Solar activity, magnetic anomalies, micrometeorite impacts. Nothing reproduced the combination of effects, not the time drift, not the trajectory shift, and certainly not the visual anomaly. Because when they cross-referenced the coordinates of Orion's path during that moment, something unexpected appeared in the mapping data. A region that had been imaged before, multiple times, by different missions, but never quite like this. High-resolution lunar reconnaissance images showed subtle inconsistencies, slight variations in shadow geometry, patterns that didn't align perfectly across different scans. Individually, they were easy to dismiss. Artifacts of imaging, differences in angle, lighting, resolution. But together, they formed something else. A suggestion, not of a structure, but of something that didn't want to be seen the same way twice. And for the first time in decades, the Moon, silent, familiar, fully mapped, began to look incomplete, Because Artemis 2 wasn't just a return to the moon. It was a return to a place we thought we understood. And the deeper the data was analyzed, the clearer one possibility became. We may have been looking at it wrong the entire time. By the time Artemis 2 completed its flyby and began the long journey back to Earth, the anomaly had already been contained. Not erased, not denied. Contained. Within NASA, information moves through layers. Raw data becomes preliminary analysis. Preliminary analysis becomes reports. Reports become statements. And statements become what the public is allowed to see. What the public saw was simple. The mission was a success. All systems performed nominally. The crew returned safely. Every word was technically true, but truth in this case was selective. Because behind those statements, something far more complicated was unfolding. Teams of engineers, physicists, and data analysts were working around the clock, not to celebrate the mission, but to understand it. The first priority was the missing 11 seconds. Data loss in spaceflight is not unheard of. Radiation can corrupt memory, hardware can glitch. But complete synchronized data absence across multiple independent systems? That's different. That suggests not failure, but interruption. When engineers reconstructed the system architecture, they found something unsettling. Orion's onboard computers hadn't crashed, they hadn't rebooted, they hadn't even registered an error. From the system's perspective, those 11 seconds had never existed. Time had moved forward. The spacecraft had continued its trajectory, but the record of that movement was gone. In physics, there is a concept known as a closed time-like curve, a theoretical scenario where space-time loops back on itself, allowing events to exist without a clear linear progression. It's a concept usually confined to equations, not real-world systems. And yet, the behavior of Orion's data suggested something disturbingly similar. A discontinuity, not in space, but in time. At the same time, imaging specialists revisited the crew's description of the linear structure. Using updated rendering techniques, they enhanced archival images of the lunar far side, focusing on the exact region Orion had passed over. What they found wasn't a structure in the traditional sense. It was a pattern, subtle, almost invisible unless you knew where to look. A series of alignments, edges, shadows, and surface variations that formed straight lines at specific angles. Not random, not entirely natural, but also not solid. Depending on the angle of illumination, the pattern would either emerge or vanish completely, as if it only existed under certain conditions. That alone would have been enough to spark debate. But when they overlaid the timing of Orion's anomaly with the lighting conditions on the surface below, the correlation was exact. The pattern had been visible at the precise moment the crew reported their sighting. And then it was gone, which raised a question that no one could comfortably answer. Was the crew seeing something that had always been there, or something that only appeared when observed? Meanwhile, the trajectory deviation presented its own problem. A fraction of a degree may seem insignificant, but in orbital mechanics, even the smallest variation has a cause. Forces don't just appear. Motion doesn't change without input. Yet Orion's systems showed no thruster activity during the deviation window, no external impact, no gravitational anomaly strong enough to account for the shift. It was as if the spacecraft had been nudged, not pushed violently, not pulled dramatically, just adjusted, precisely, deliberately. That word began to appear more frequently in internal discussions, not in official reports, but in private analyses. Because randomness has a signature, it creates noise, inconsistency, unpredictability. What they were seeing wasn't noise. It was consistency without explanation, and that is far more difficult to dismiss. As the days passed, another layer of data came under scrutiny. Biometric readings from the crew, heart rates, neural activity, stress indicators. During the 11-second gap, all 4 astronauts exhibited a synchronized spike in neural irregularities. Not panic, not fear, but something closer to confusion. A brief disruption in cognitive coherence, as if their brains had processed something they couldn't fully interpret. And then, just as suddenly, the readings returned to normal. No lasting effects, no medical concerns. But the pattern was there. 4 individuals, isolated from Earth, experiencing the same unexplained event at the exact same moment. That kind of synchronization doesn't happen by chance. Eventually, the question shifted. It was no longer just about what had happened. It was about why it had happened there. The far side of the moon has always been a place of absence. No Earthrise, no radio signals, no direct observation from the surface of our planet. It is, in many ways, the most isolated environment within reach of human exploration. And isolation changes things. It removes interference. It strips away background noise. It creates conditions where subtle phenomena, ones that might go unnoticed elsewhere, become detectable. If something unusual were happening on the moon, the far side would be where you'd expect to find it. But that leads to a more unsettling implication. If it's been happening all along, why haven't we seen it before? The answer may lie in how we observe. Every lunar mission prior to Artemis 2 relied on predictable parameters. Fixed orbits, predefined imaging schedules, limited angles, controlled variables. We looked at the moon the same way, every time. And in doing so, we may have been missing something that only reveals itself under very specific conditions. Conditions that Artemis 2, intentionally or not, happened to meet. A slightly different trajectory, a slightly different timing, a slightly different perspective. Just enough to expose something that had remained hidden in plain sight. In the months following the mission, discussions began about Artemis 3, the planned return of humans to the lunar surface. Officially, the focus remained on the South Pole, where water ice deposits offer the potential for sustained exploration. But quietly, another proposal emerged. A reconnaissance mission to the far side. Not publicly announced, not formally approved, but seriously considered. Because once you've seen something you can't explain, you don't ignore it. You go back. And that is where the real tension lies. Because whatever Artemis 2 encountered, it didn't behave like a passive feature of the landscape. It appeared briefly. It disrupted systems. It left no clear trace. And then it was gone. Not destroyed, not moved, just no longer visible, which forces a final, uncomfortable possibility that the moon is not just a place we haven't fully explored. It may be a place that doesn't fully reveal itself. And if that's true, then the next mission won't just be about discovery. It will be about whether we are ready to see what the moon has been hiding when it decides to show us again.